So welcome to my new video on uh, differentiation of a to the power x with respect to x. Here a can be any value and x is the independent variable of the function a to the power x. So let us take first as an example a is equal to 2. So the function, let us take a function if x is equal to 2 to the power x. So we can write, if we increase x by del x, then f x plus del x would be 2 to the power x plus del x. So with the concept of limit, we can write that differentiation of 2 to the power x with respect to x, which can also be denoted as f dash x, is equal to, would be limit del x tends to 0, 2 to the power x plus del x minus 2 to the power x divided by whole divided by del x. So if we simplify this thing, we can get limit del x tends to 0. We can take 2 to the power x as common, and in the inside bracket we will put 2 to the power del x minus 1 whole divided by del x. Now in this case, as del x is tending to 0, if we take a value which is close to 0, say we take del x as 0.01. If we put it in a scientific calculator, we would get, let me calculate it first, we would get 2 to the power x multiplied by, let me do a quick multiplication in my scientific calculator. Minus 1 divided by 0.01. It would take the value of 0.6955550057 according to my calculator. Now if we take a much closer value to 0, say 0.001, it would take a value of this. Now if we take a as e, that is exponential e, which obviously we know the value of e, everybody knows the value of e, that is, let me write it in a different color. E, exponential e is 2.7188281828. This is the value of e. Now if we take another function of x, say gx, as e to the power x, similarly we can write would be e to the power x plus del x. Similarly, if we take the derivative of e to the power x with respect to x, or we can write it in this way, this would be limit del x tends to 0, e to the power x plus del x minus e to the power x divided by del x. If we simplify the whole thing, it would become let me take in the difference. Next slide, next page. It would become, say if we take del x is 0.001 close to 0, we can take any value close to 0 obviously. It would become e to the power x multiplied by, let me do it quickly, 1.005, sorry, 1.000500167. In this way we can see, if we take much closer value to 0, more close values of del x to 0, we would get ultimately this value. It would approach 1 as del x approaches 0. This value will be approaching 1 as del x approaches 0. As in the, so what is 1? We can say, just for an information, if a to the power x is b, then we can write log b base a is equal to x. So we can write obviously log 10 log 100 base 10 is equal to 2. So what will be 1? We can write log a base a is equal to 1. Or obviously similarly log e base e is equal to will be 1. This log e, the base e, is called as natural logarithm, which is denoted as ln. Any log which has e base and say log b base e, we would write it as ln b. So here 1 we can write as ln e, or simply e to the power x, because this is 1. Now as we have seen here, this value, what is this value? If we calculate ln 2, or as I said log 2 base e in our calculator, we would see the value of, let me take a different slide, ln 2 would give a value of 6931471,806. So we can see as del x here, in for this function, as del x approaches 0, this value approaches ln 2 or log 2 base e. So for any a, let me take a different color. So for any a, dx of a to the power x, that means it can be shown, let me write it again, it can be shown similarly as 2 to the power x, as 2 to the power x, as d dx of 2 to the power x, that for any a, differentiation of a to the power x with respect to x would give a value of a to the power x multiplied by ln a. So this video was about such proof, this proof. we'd do some problems, some different kinds of problems on differentiation in my next videos. Till then, bye. And if you like my videos, please like, subscribe to my page, and share to your friends. Thank you.